welcome to Friday Math Math Happy Hour. Today I'm going to cover some topics that might be on your exam. For example, not all these topics are in my exams because there's too many topics. But I chose more or less the topics that most instructors will give some of these on the final exam. So I'm going to cover linear equations, quadratic equations, applications on linear and quadratic functions, exponential functions, applications on exponential functions, solving exponential problem, finance applications, solving systems of equations, matrices, sets and Venn diagrams, probabilities, and finally permutations and combinations. So to start off, let's start off with linear equations. So here's a question. It says find the equation of the line passing through the point -2,5 and -4,6. So they want the line in slope-intercept form. Okay, so the equation in slope-intercept form is equal to y equals to mx plus b. So I need to find my m, which is my slope, and I need to find the y-intercept, which is a b. So there's a formula that's called the slope formula, right? M is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So from the 2 points, right? The points that were given, that's why I get my x1 and y1 and x2 and y2. For example, this is my x1 is -2, my y1 is 5, my x2 is -4, and my y2 is 6. So we're going to plug into the formula. So it's going to be y2 minus y1, which is 6 minus 5, and x2, which is -4, minus x1, which x1 is -2. So let's simplify. This will be 1 on the numerator, and on the bottom, this becomes -4. The two negatives become a positive, so -4 plus 2 will give us -2. So my slope is equal to -1/2. I found my m. Now, to find the b, I believe the book uses another formula, but I believe this formula is much easier. That's why I stick to b equals to y minus mx. So all we do is to solve for b, we're going to choose one point. It does not matter which one, either the -2,5 or the -4,6. Okay, so I decided to use the -2,5. Okay, so I'm going to plug everything in. B equals to y minus mx. My y is 5. My x is -2. And my slope is the slope that we just found, which was -1/2. So there's my y. This is my y. My y is 5 minus my slope is -1/2. You know what, guys? I did a mistake here. This is supposed to be -1/2 here. Then negative. I forgot to put the negative there, guys. Okay. So then this will be, if this is negative, this will be let's see here. This will be negative. Will be +1. So yes, but this is correct. But this should be negative right there. But the answer is correct. It's b equals to 4. But this should be negative, right? Because -1/2 times -2 will give us a +1. Then 5 minus 1 will give us a 4. So this is my result. Y equals to -1/2 x plus 4 again. This should be a negative right there on the 1/2. But the b is correct, right? Because like I repeat, if I put a negative here for the 1/2, which it should be a negative, -1/2 times -2 will give me a +1, and then 5 minus 1 will give us a 4. So this is the equation that we're looking for. Okay. Y equals to -1/2 x plus 4. Now, this is also crucial if you're going to be taking the next course, which is the 1325, which is students going for business or for accounting. This is crucial because you have to know the different quotients in the next course if you have to go that far. So anyway, the function that they gave us is f of x equals to x squared minus x plus 4. So for the solution, at first I need to find this part here, the f of x plus h, which means I'm going to go to every x and plug in x plus h. See? So I'm going to plug it here, x plus h for the x here, and x plus h for the x, for the minus x here. Now here, I have to do the FOIL. X plus h squared is equal to x plus h times x plus h. So if I do the FOIL, x times x will give me x squared. X times h will give me xh. Then h times x will give me xh. And h times h will give me h squared. So this reduces to x squared plus 2xh plus h squared. Okay. Now we have minus x plus h, right? These, we just bring them down. Now we're going to simplify. So we have x squared plus 2xh plus h squared. This will give us negative x minus h plus 4. Now I'm going to do the f of x plus h minus f of x. This is done like in 3 steps. Okay. So I already know what the f of x plus h is. I just got it right. I just solved for that. Now the f of x is a given function, right? That's my f of x plus h, and that was a given function from the beginning, which is x squared minus x plus 4. Now here's a common mistake that students make. They don't put the parentheses, and then they just have the x squared as negative. That's a mistake, because then they leave the negative x as it is and the 4 as it is. But if you put it with parentheses, it means that you have to distribute. There's like a negative 1 here, right? So negative 1 times x squared will give us negative x squared. Negative 1 times negative x will give us a positive x. And negative 1 times positive 4 will give me a negative 4. Now I have to simplify. I tell my students that there's like a observation here, what the answer should look like. I tell my students, if the terms here, if they don't have an h, they have to cancel. For example, does x squared have an h on it? No. So there's somewhere it has to be a negative x squared. You see? Okay, term without an h will be eliminated. So the x squared will be eliminated with the negative x squared over here. The 2xh, does it have an h? Yes, so that one stays. Right? The a squared, does it have an h? Yes, it stays. The negative x doesn't have an h, so somewhere there has to be also a positive x, and here it is. Cancel. Does this term the h have an h? Yes, it does, so it stays. Does the 4 have an h? No, it doesn't, so there has to be a negative 4 somewhere, and here it is at the end. So again, the hint is every term that has an h will stay. You see the 2xh plus h squared minus h. Now comes step 3. Right, so here I'm going to factor out an h. Why? Because in step 3, I'm going to cancel this h with the one on the bottom here on the denominator. You see? So that's my result, 2x plus h minus 1. And again, this is crucial if you're taking math 1325. Okay. Let's go to number 3. Number 3, it's saying the manufacturer's suggested retail price, which is a MSRP for a base model 2016 Toyota price, is $25,035. And it is expected to be worth $14,115 in 4 years. So this is a 3-part question. The first part, they want you to find the linear depreciation function for this car. Then for B part, estimate the value of the car in 5 years from now. And at what rate is the car depreciating? So from the initial sentence, we have to find 2 points. Okay. So right, when the car is brand new, right? So the car is brand new in 2016. So the original price is $25,035. So this is y equals to $25,035, right? And this is my x. My x is 0 because no time has passed by. So my point 1 is going to be 0, 25,035. Now, the second step, in 4 years, right? In 4 years, the car will be worth 14,115. So x equals 4 and y equals to 14,115. So that's my second point. It will be 4 and 14,115. Now we're going to find the equation, how we did it, and I believe in problem number 1. Given 2 points, find the equation of the line in slope intercept form. But now The only difference from problem number 1 is that this is a word problem. Okay, so I need to find my slope and the y-intercept. So for the slope, again, we're going to use the formula. So here, guys, it's going to be this is x1 and y1, x2 and y2. So it's going to be y2 rep, which is 14,115, minus y1, which is 25,035, and x2, which is 4, minus x1, which is 0. So there's my setup. So we get negative 10,920 over 4, which becomes negative 2,730. So that's my slope. Now, to find my b, right, we're going to b equals to y minus mx. So it's easier to use the first one, the 0 to 25,035. So y is 25,035 and x equals to 0. And my slope is the one that we just got right now, which is negative 2,730. So we plug everything in, right? There's my y, 25,035, minus, this is my slope, my m, the negative 2,730, and my x is 0. So my b is 25,035. So what's my function? There's my slope, there's my y-intercept. So it's going to be f of x equals to negative 2,730x plus 25,035. That's the answer for A part. Okay, here we go. Now for B, estimate the value of the car in 5 years from now. So we're going to be looking for f of 5, right? We're going to plug in 5 for the x. So, right, so we're going to plug in the 5 for the x here, right? Which is negative 2,730 times 5 plus 25,035 will give us 11,385. So the car will be worth in 5 years is $11,385. Okay. Now C. At what rate is a car depreciating? That the rate of change is your slope. So for C part, the slope is going to be, right? What's the slope? The car is depreciating at $2,730 per year, right? You don't have to put the negative because we know depreciating means negative. Okay, so be real careful on this one because if you put negative, the answer is wrong. Okay, but I will give you partial credit if I was your instructor. But depreciating means that this is going to be negative. That's what it means. Okay, now let's move on to number 4. Hey students, if you have any questions as we go along, please put it in the chat or just get on the mic and let me know. Because I don't have the other computer, so I don't see the chat or nothing. I don't have no access, but Patricia will help me out here. Okay. Now, number 4 is find the vertex, axis of symmetry, y-intercept, and x-intercepts of the function. The function is f of x equals to x squared plus 10x plus 9. So solution, right? So the function, we have to know what the a, what the b, and what the e stand for. Okay, what's the value for those? So this is my vertex, negative b over 2a, and f of negative b over 2a. This is the axis of symmetry. So once I find the vertex, the x part of the vertex is the axis of symmetry. But it has to be x equals to negative b over 2a. For the y-intercept, it's going to be 0c. And the c is always the constant without, that doesn't have a letter or it's called a variable. Okay. And for the x-intercepts, we got a factor. Okay. So the first thing we're going to do is find the vertex. So I have to know what the a and the b are, right? So my a is 1 because there's nothing there, right? So we know it's a 1, and my b is 10. So negative b over 2a will be negative, right? Negative, and my b is 10, and my a is 1. So this will give us negative 5 because negative 10 divided by 2 times 1 is going to be negative 5. So that's my x part of the vertex. Now for the y part, all this means here, guys, because here the formula for the vertex, at times students get all freaked out, they get all panicky because they haven't seen that before, and that might be a little bit intimidating, but this is not that complicated. Once you find the x value, this part here, that f of negative b over 2a, means that you're going to plug in this value back into the original problem. Right, so I'm going to plug it in here, and also in here for the x squared, and also for the x here. So I'm going to plug it in there, and also in there. And the answer will be negative 16. Okay, so what's my vertex? Negative 5, negative 16 is your vertex. Now, once you find your vertex, again, you also found the axis of symmetry, because the axis of symmetry is the x value of the vertex, x equals negative 5. You have to put x, guys. A lot of students, they don't put x equals, they just put the number, which is wrong, because the axis of symmetry is actually a line. Okay, that's what it's called, the axis of symmetry. So that's the axis of symmetry. Now for the y-intercept, hey guys, the y-intercept is very, very visual. You should have known what the y-intercept is right from the beginning. The y-intercept is always the constant or the number that doesn't have an x or a variable. So it's going to be 9, right? Or you can write it as 0, 9. So this is my y-intercept. Now for the x-intercepts, you have to know how to factor. We let the function equal to 0 and solve for x. Right, so this will give you x plus 9 and x plus 1. If you guys struggle with factoring, I believe I did a workshop on week 3 on factoring. Maybe you can go back and review factoring, okay? Because that's another topic there. Anyway, here we're going to use the zero property theorem, which means that x plus 9 must equal to 0, and also x plus 1 must equal to 0. So here we subtract 9 to both sides, so x equals to negative 9. And here we subtract 1 to both sides, x equals to negative 1. Those are my x-intercepts. Okay. Okay, now let's find the vertex of symmetry and y-intercept and x-intercept functions with another form of a quadratic function. This form is called in vertex form. Okay, so if it's in this form, the vertex will be hk. The axis of symmetry will be h. The y-intercept, right? You have to let x equal 0 and solve for y. And for the y and for the x-intercepts, you're going to let y equal 0 and solve for x. Because on this one, the vertex is very, very, you can actually see it. Okay, because the vertex is going to be the 3 and the 16, negative 16. But it's always the opposite for the h here, right? So my h will be negative 3. And my y will be negative 16. Again, the here from the x plus 3 squared, right? It's always the opposite of what's here. If the opposite of 3 will be negative 3. So that's the vertex because this is the formula. And the case that stays how it is. So it'll be negative 16. So this is my vertex. So once you find your vertex, you also found the axis of symmetry, which will be my h part, right? My h part is the x part of the vertex, which will be, now again, that's your vertex. So that'll be x equal to negative 3. So now, for the y-intercept, we have to let x equal, we have to let x equal 0. So if we plug in 0 here, right? Don't we have 3 squared minus 16? This will be 9 minus 16 will give you negative 7. So this is my y-intercept, negative 7. Okay, 0, negative 7. So for my x-intercept, we're going to let y equals 0 and solve for x. So this is the same thing as y, right? So we have y here, so we're going to let y equals 0 and solve for x. So I'm going to add 16 to both sides. Then I'm going to take the square root of both sides, right? I just put this over here on this side and the 16 on the right side, which is okay. But when you take the square root, guys, this becomes positive or negative. When you take an even root, right? Because the square root is an even root. So every time you take an even root, you're going to put positive or negative. If there was an odd root, then you don't have to put the plus or minus. So we have x plus 3 equals to positive or negative 4. So it's going to be subtract 3 to both sides. So it's going to be negative 3 plus 4. And negative 3 minus 4. So we're going to get x equals to 1 and x equals to negative 7. These are my x-intercepts. Okay. And I believe also you have to graph them, okay? But for example, in my exams, they have to graph them, but I didn't graph them here, guys. Okay, but to graph them, how you do is plot all the points and make your parabola. Okay. Okay, now this is number 6. Here I'm applying what we just learned in actual word problem. Okay, so it says here number 6. The revenue for McDonald's Corporation in billions of dollars for the years 2015. You know what, guys? This is supposed to be from 2010 to 2015. I made a mistake here. This would be a 10 here. Okay, and this should be 2015. Can be approximated by the quadratic function r of x equals to negative 1/2 x squared plus 13x minus 57, where x equals 10 corresponds to the year 2010. So this should have been a 2010 here, guys. My apologies. Okay. So now they want you to find the vertex. In what year during the period was the revenue at a maximum, and what was the maximum revenue to the nearest $1 billion, guys? So here, guys, all we have to do is find the vertex. Once we find the vertex, the B part will be the X part of the vertex, and the Y part will be the C part of the vertex. Okay. So solution. So for the vertex, right as before. So my A is negative 0.5 or negative 1/2, and my B is 13. So if we plug into the formula, negative B over 2A is going to give us negative 13 divided by 2 times negative 0.5, because my B is 13 and my A is negative 0.5. So this gives us negative 13 over negative 1, which is 13. Now for the Y part, right? So I'm going to plug in 13 on the original function, which is the r of x equals to negative 1/2 x squared plus 13x minus 57. So I'm going to plug in the 13 for the x's there, which are here in blue. So it's going to be 27.5. So what's my vertex? 13, 27.5. So that's the answer for A. Okay. Now what's the answer for B? In what year during this period was the revenue at a maximum? So, right, so if x equals 10 corresponds to the year 2010, so then 13 will correspond to the year 2013. So that's the answer for B, is in 2013 was the revenue at the maximum. Now for C part, what was the maximum revenue to the nearest $1 billion? So I know that the Y value of the vertex is the maximum revenue, right? So 27.5 round off to the nearest billion, so it's going to be 28 billion. So the answer will be 28 billion for part C. And that's how we use the vertex in our problem, guys. Okay. Number 7, solve the exponential equation. So here, they're going to give us 9 to the x power equals to 27. So here, guys, we're going to try to find the same base. So 9 squared will not give me 27, right? So that means that I have to find the common base between 9 and 27. So, right, so then the 9 equals to 3 squared, and 27 equals to 3 cubed. So I'm going to replace the 9 with 3 squared, and then bring down the x, and I'm going to replace the 27 with 3 cubed. Now, here, guys, I'm going to apply the exponential property rule, or the power rule. So here, guys, it means that if you have a power raised to another power, you multiply the powers. That's what the rule states. So now we have the same base, right? So if you have the same base, then the exponents must equal to each other. So 2x equals to 3. So we divide both sides by 2. So the answer will be x equals to 3 over 2. Now, you can always check your solution, right? So we know the answer is 3 over 2. So let's plug it back into the original. Okay. So if you plug in the calculator, guys, it's going to give you 27 equals 27. And I believe, let me go back. I believe on, I think on week 5, I did cover this topic, and it shows you how to do this without a calculator. Okay, and I believe I explained that there. Okay, so let me move on then. Okay, now this is number 8. This is how you use an exponential function in real life. The assets in billions of dollars for the Prudential Financial Incorporated can be approximated by the function a of x equals to 315 e to the 0.056x, where x equals 7 corresponds to the year 2007. Find the assets for the following years. So for the year 2000, right? So for the year 2000, it's going to be x equals to 0, right? Because if x equals 7 corresponds to 2007, then x equals 0 corresponds to the year 2000, and x equals 12 corresponds to the year 2012. So for a part, I'm going to find a of 0, which means I'm going to plug in 0 for the x, which will give us 315 e to the 0, which will be 315 times 1, which will be 315. So the answer will be $315 billion. For part B. Okay, now, this is something extra, guys. Good to know. 315 is the initial value because time is equal to 0. So when time hasn't gone by, right? So that's my initial value, which is 315 from the formula. Okay, now B. A of x equals to 315 e to the 0.056x. So now for B part, we're trying to evaluate A of 12, right? Because that's in 2012. So we're going to plug in 12 for the x. Okay, here I also make a notation here. Some of the calculators, guys, if you don't put it in parentheses, you're going to get the wrong answer. It depends on what type of calculator you're using. But to play safe, put the exponent and also the operation, which is multiplication, right? Multiplying by 12, put everything in close parentheses to avoid mistakes. If you do that, this will be your answer, guys, 616.8171575. And round out to a nearest billion. Here they rounded off to right to a nearest 10. So it's going to be $616.8 billion. Okay. Okay, now, hey guys, this problem here, I came up with it when COVID started back in 2020. I believe I wanted to share this because we were covering this topic here right before COVID, right before we went to spring break. And I believe after spring break, the classes, they went virtual. So I wanted to tell my students how we can come up with a function to more or less approximate how many people would be infected in time. Okay, so I use this as an example. A deadly virus has infected the world. At the end of January, there were 2 cases, and by the end of April, the cases had grown to 128. I believe I got this information from the news. I think in April, in January, that's when it started with 2 people in Washington, I believe. And then by April, there were 128 cases, or maybe even more in the United States. But this is just an example here. So for A part, it says find the model of the form f of t equals to y naught b to the t power, with t equals 0 corresponding to the end of the month of January. Okay. So from here, guys, we have to find 2 points. Okay. And then for B part, if the trend continues, about how many people will be infected by the end of the year? So we need to find y naught and b, right? That's a strategy for part A. Y naught is the amount present at time t equals 0. And remember on the previous example that I showed you guys, and I said that was the initial value. That is good to know. Well, here it is, guys. When time hasn't passed, then the initial value will be corresponds to the end of January, which will be the 2 cases, right? So Y0 is equal to 2. So here, guys, so if T0 corresponds within the January, then T1 corresponds within the February, and T2 corresponds within the March, and T3 corresponds to the end of April, right? That's what we want here at the end of April. So at the end of April, there were 128 cases. So let's use the formula, guys. So we can go straight from here to here, but I did every month so you guys can see how we got 3 for April. So use what we know to find B. Okay. So this is my function that we want for part A. Okay, we know that f of 3 equals to 128, right? Because in April, right, which was 3 months after it started, there were 128 cases, and we know that Y0 equals to 0. So let's plug in everything into the formula. So f of 3, right? F of 3 is 128 equals to 2 b to the third power. Why 2? Because my Y0 is equal to 2. You see, everything is color coded so you guys can see where everything came from. So here we're solving for B. And again, f of 3 equals to 128, right? So 128 is here. And also for T, because 3 months have passed, the 3 is also in blue. That way it matches the point. So the first thing here, guys, we're going to divide everything by 2. So that'll be what? 64 equals to b to the third power. We take the cube root of both sides, or raise both sides to the 1/3 power, right? And here we apply the rule, right? With the power rule, when we have a power to a power, we multiply the powers. So here, guys, 3 times 1/3 will give us just b. And 64 to the 1/3 power, we get 4. Guys, if you want, you can plug this in the calculator if you guys don't know how to do it by hand. You put 64 to the power of parentheses 1 divided by 3, and it's going to give you 4. So I got my b, and I got my Y0, my original value. So let's plug them into the formula. So this is the formula for part A. F of t equals to 2, parentheses 4 to the t power. Now, for part B, from January to December, it's going to be 11 months, right? Because we have January, right? This is, if you want, you can follow the sequence here. T1 corresponds to the end of February. T2 corresponds to the end of March. T3 corresponds to the end of April. If we keep going, December will be 11. Okay? So then we're going to find f of 11 to see how many cases were there by the end of the year, by the end of December. So we're going to plug in 11 on the formula for the t also, right? So here for the t, right, 11 months. So this, how many cases will they be by the end of the year? I know there wasn't that many cases here in the US by that time because there was intervention. But if there was no intervention, that more or less that'll be the rate that the virus would be spread. But with intervention, there was face masks, there were social distance and stuff like that. That's why it prevented to get much worse than what it really was. But anyway, guys, this is how you use a real situation in the world, how we use math to actually come up with a formula and how to predict or estimate how many people would be infected in a certain amount of time. Okay, now, number 10, I believe it comes from chapter 5. Okay. It says Gabriel invested his summer earnings of $3,000 in a savings account for college. The account pays 1.5 simple interest. What will be the value of this account after 2 years? And how much interest did he earn? So right away, guys, here there's a key word to see what formula we're going to be using. And the key word is simple interest. For simple interest, this will be the formula for simple interest, right? And again, this signifies simple interest means this will be the formula. So I have to find what everything is, what my future value, present value, my R and my T. So here, guys, from the word problem, we have to extract the information and put it into the formula. Okay, now, what are we looking for? If you notice here, what will be the value of the account after 2 years? So we're looking for the future value because 2 years from now is the future. So we're looking for the future value. So the 3,000 has to be the present value. The interest rate is always in a percent symbol. So the interest rate will be 1.5%. You have to convert it to a decimal, which will give us 0.015. And the T stands for time, is going to be 2 years. So plug everything into the formula, how it is. Right, use your calculator. You'll get 3,090. So that's the answer for the first part, right? Now for the second part, how much interest did he earn? So the interest is a future value minus a present value. So the future value was 3,090, and the present value, the initial investment, was 3,000. So the answer will be $90. So Gabriel got $90 extra in interest in those 2 years that he invested his money. Okay, there's the answer for the first part, and there's the answer for the second part. 3,090 and $90 total. Okay, now, number 11. Okay, it says here, you deposit $9,000 in an account at your bank that pays 2.5 interest semi-annually. How much money will be in your account after 10 years? And how much interest did you earn? Okay, now, this, what distinguish here, or what let us know what's the formula. Guys, here where it says interest semi-annually, right, this means compounded at times. The word compounded is there, but at times it's not there. So where it says semi-annually or quarterly or monthly, it means it's going to be a compound problem. This is something from, I believe, 5.2. Okay, so this is a formula that you're going to be using, which I believe this will be a better formula, which the I is equal to R divided by N, and the N is equal to M times T. So there's 7 things that you got to find. Okay, and this is easier to input in the calculator. So there's 7 things, right? There's 1, 2, 3, 4, 5, 6, 7. So we have to extract the information from the word problem. Okay, again, here it says how much money will be in your account after 10 years. So we're looking for the future value. So the 9,000 will be your present value. The 2.5% will be the interest rate, converted to a decimal, 0.025. The M stands how many times it's compounded per year. Semi-annually stands for 2. The time is in years will be 10. Now the I is equal to R divided by M. So my R is 0.025 and my M is 2. So it's going to be 0.025 divided by 2, which will give us something like 0.0125. Okay, now here guys, if it didn't give me like a good finite number, if the number discontinued, be real careful when you round off, because you don't round off now until the very end. At the time, the instructor or the homework or the My Math Lab wants you to round off to a nearest penny. So if you don't put this, I mean, if you round off here, then you're going to get a wrong answer. Okay, so make sure that, just be careful with that. And the N is equal to M times T, so it's going to be 2 times 10. So the answer is 20. So all we do is plug everything into the formula. There it is. And just use your calculator, and this is the result. So the result is $11,538, 0.33509 cents. So we round out to a nearest penny, so the answer will be 0.34, right? Instead of 0.33 here. So it's going to be 11,538 and 34 cents. How much interest did you earn? So again, for the interest, it's going to be interest earned equals to future value minus present value. So that's my future value, what we just saw for, minus the 9,000, which was the present value. So the answer will be $2,538.34. That's how much money was earned in interest. Okay, now solve by graphing. Okay, so here, guys, this is a system of equations. Okay, you're going to solve by graphing. So here we're going to have to graph both equations, and where the lines meet or they intersect, that'll be the solution. So equation 1, right? So equation 1, we know my slope is 3, 1, right? So that means, so this is my slope is going to go up 3 and 1 to the right. From where? From the B. The B is a y-intercept, which is -6. So the 0, -6 is your starting point, right? Which will be right about here, right? 0, -6. And then I'm going to go up 3, 1, 2, 3, and 1 to the right. And you want, right? If you want, you can keep going 1, 2, 3, 1, and so forth, right? But how do we graph a line? It only takes 2 points to graph a line. So all we do is make the line out of the 2 points. Then we go to equation number 2. Equation 2 was -5x minus 2y equals to -10. So I need to put it in the form of y equals to mx plus b. So first of all, I'm going to add 5x to both sides. Right, so we get -2y equals to -5x minus 10. Then we divide both sides by -2. So this is the result. Y equals to -5/2x plus 5. So here, guys, my slope is -5/2, which means I'm going to go down 5 and 2 to the right. From where? From my B, which is a y-intercept, 0, 5. So 0, 5 is my starting point, so it's going to go up here, right, on the graph. 0, 5. I'm going to go down 5. 1, 2, 3, 4, 5, and 2 to the right. 1, 2. So there's my other point. We connect the dots with the points, and that's my line. So what's my answer? The answer is where they intersect. The answer will be 2, 0. That's my solution. Okay, now solve the system by the elimination method. So this is another way to solve the system. You can do it by graphing, by substitution, or by the elimination method. Here, they're asking to solve it by the elimination method. In order to use the elimination method, it has to be in a certain form. Okay, this is equation 1 and equation 2. So both have to be in the form of ax plus by equals c. If you notice, equation 1 is not in that form. So I have to rewrite it in proper form. So I'm going to add 2y to both sides. So we get x plus 2y equals 19. So now it's in proper form. So that becomes the rewritten equation 1 and equation 2. So here, guys, I need to get rid of the x's or the y's. It doesn't really matter what you want to get rid of. But there's always, if you look at both equations, it'll be easier to get rid of the x's. Why? Because if I multiply the whole equation 1 by -4 and add it to equation 2, the x's will be eliminated. Okay? And like I said, whatever is easier for you. Multiply by -4, we get -4x, and -4 times 2 will give us -2y, 8y I mean, and -4 times 19 will give us -76. Equation 2, we just bring it over how it is, and then we do the operation, right? So these will be eliminated. So we're going to get -11 8y, I mean -11y equals to -77. We divide both sides by -11. So we get y equals to 7. Then you have to go back to equations 1 or 2. Whatever is easier for you. You're going to plug in 7 for y and solve for x. So here, guys, right? So we go back to the original ones. In my opinion, it's easier to go to equation 1 because x is already isolated. So all we need to do is plug in a 7 for y, and we have it. We have the x value. So again, I'm going to use equation 1. So I'm going to plug in 7 for y, right? There's my y right there. So I'm going to plug it in there. -7 will give us -14 plus 19 will give us x. So what's my solution? 5, 7. Okay. Now, how do we use that type of problem? How do we use what we just learned in a word problem? Well, here it is. It says a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? Okay. So here, there's like a little strategy here. We're gonna let x. Okay, we're gonna do seats with seats and money with money. So we're gonna let x equal to the adult tickets. and let y equal to the children's tickets. And here's what the number of adult tickets plus the number of children's tickets or seats must be equal to 200. So it's going to be x plus y equals 200. Now let's do the money with money. So if if adult tickets are $8, then this will be 8x. In a similar fashion, if the children's tickets are $5, then that will give us 8y. And what was the total amount or the total revenue? Was $1,435. So there it is. So it's going to be 8x plus 5y equals to 1,435. Now we got both equations. Now we can solve it by substitution, by elimination method, or by graphing. It's easier to do it by the elimination method because they already set up in that form. Okay. So now here we can get rid of the x's or the y's. What's easier? I'm going to get rid of the x's. So I'm going to multiply every term or the both sides of equation 1 by -8. So -8 times x will give us -8x, -8 times y will give us -8y, and -8 times 200 will give us -1600. And equation 2, we'll just bring it over. Now we add the terms. So there'll be the x's will be eliminated. So -8y plus 5y will give us -3y, and -1600 plus 1435 will give us -165. We divide both sides by -3, so y equals to 55. So I found the y value. Now I need to find the x value, right? So I need to plug in 55 for either equation 1 or 2. I'm going to choose equation 1 because it's easier, right? Because it seems much simpler than equation 2. So y is 55, so I'm going to plug in 55 for the y is, right? So the y was right there, so I plug in 55 there for the y. Then I subtract 55 to both sides, and x equals to 145. So x equals 145 and y equals to 55. So x represents adult tickets or adult seats, and y represents children's seats. So there's my answer, what you're looking for. Okay, so this is how many people were in the attendance: 145 adults and 55 children. And again, this is how you apply solving systems of equations in like a real life applications problems. Okay. Now, this is a Gauss-Jordan method for solving systems of three systems of equations. Okay. And again, this is kind of challenging for students, but one of my students asked me, I think last year or something, Mr. Isasi, well, why do you give us something this hard in the exam? It's because you need it if you need to take, again, the 1325 course. You need it for chapter, I believe, chapter 7, because it starts in chapter 7. So they use something similar to by using the Gauss-Jordan method. That's why I decided to put it in there. I don't really give it in my exams, but some instructors might. So here, all the topics that I have here covered, guys, is something that are like crucial problems from every chapter. So I just put it in here because you need to know it for 1325. Okay, now, so I believe I did this PowerPoint on, I don't know what week, but it was for chapter 6. Okay, solving systems of equations. So here, guys, so I'm going to do it in 3 steps. This is step 1, step 2, and step 3. So here we go. So step 1, we keep row 1 how it is, because this is considered row 1, row 2, and row 3. So the 2 must be a 0, and also the -1 must be a 0. Okay, so I'm going to use row 1. So I'm going to multiply -2 times row 1 and add it to row 2. In a similar manner, right? If I add row 1 and row 3, that will be a 0 there, because the first step is that these 2 must be zeros. So that's what I'm trying to do in step 1. So I'm just going to add them, row 1 plus row 3. And here's my work. So -2 row 1 plus row 2. So I get -2 row 1, right? So I'm going to multiply -2 times every term here, or just distribute. So it's going to give us -2, -4, 2, and -12. And I repeat, I got this by multiplying -2 times 1 is -2, -2 times 2 is -4, and so forth. Plus row 2. There's my row 2. So all we do is bring it over. Right? Row 2 is 2, -1, 3, 2. So now we add them, right? So we get 0, -5, 5, and -10. And like I mentioned on this PowerPoint, when I was doing this section, you always simplify if possible. So here, guys, because if you don't simplify, it gets a little bit more challenging if you don't simplify. So here, guys, I can divide everything by -5, correct? So if I do that, I'm going to get 0, 1, -1, 2. Because -5, if I divide 0 by -5, it's going to give me a 0. -5 divided by -5 will give me a 1. 5 divided by -5 will give me a -1. And -10 divided by -5 will give me a +2. So this is my new row 2. Now for the second part of step 1, I'm going to add row 1 plus row 3. So after I do the operation, I get 0, 1, 0, 1. So this is my new row 3. Now comes step 2. So step 2, row 2 stays the same. Now the object here is that I need to make the 2 a 0 here on the first row, second column, and also the third row, third column. I need to make the 2 in this one be equal to 0. So this got to change, and the third row is got to change. So then I'm going to be using row 2. So I'm going to multiply -2 times row 2 and add it to row 1. I'm going to multiply -1 times row 2 and add it to row 3. And here's my work. So -2 row 2, right, will be -2 times 0, 1, -1, 2, right? Here's my row 2. That's what I'm multiplying -2 by. So after I distribute the -2, so I get 0, -2, 2, and -4. Plus row 1, I just bring row 1 over. So row 1 is 1, 2, -1, 6. And after I do the operation, it's going to give me 1, 0, 1, 2. So that's my new row 1. And in a similar fashion, I'm going to do the same thing for the second part of step 2. -1 row 2 plus row 3. So -1 row 2 will be -1 times every term, times every number in row 2. So I get 0, -1, 1, and -2. Now if I add it to row 3, I get 0, 0, 1, -1. So that is my new row 3. If you notice, guys, this is step 1 to make these zeros. This is step 2 to make these 2 zeros. So step 3, I need to make these 2 zeros here. So step 3, I'm going to use row 3. So row 1's got to change and row 2's got to change. Okay, so I'm going to multiply. Right, we have a 1 here and a 1 here. So I'm going to multiply -1 times row 3 and add it to row 1. And here I'm just going to add these two, row 3 and row 2, and that guarantees me it's going to give me a 0. So here's my work. So -1 row 3 will be -1 times row 3. Row 3 is 0, 0, 1, -1, right? So if I multiply -1 by all those numbers, it's going to give me 0, 0, -1, and 1. Now all I do is bring row 1 over. Row 1 is 1, 0, 1, 2. So after I do the operation, it's going to give me 1, 0, 0, 3. That's my new row 1. In a similar fashion, I do the second step, row 3 plus row 2. So it's going to give me 0, 1, 0, 1. That's my new row 2. This means that x equals to 3, y equals to 1, and z equals to -1. That's my solution, guys. Okay. So let's move on. So now, here we're going to be multiplying matrix, right? So we're going to multiply the matrix by a scalar. So for sure it says to find -4 times matrix A. I know, guys, I'm probably going to pass the time. I'm probably going to do like another 20 minutes. And sorry for all this, because I am going to go over, but I believe it's important, and I don't want to leave you guys like halfway. So I am going to finish the PowerPoint. So here we have negative 4 times A, right? So negative 4 times A means negative 4 times matrix A, which means I have to multiply negative 4 times every element in the matrix. Okay. 4 times negative 2, 4 times 0, negative 4 times 5, and negative 4 times 3. But if you want, guys, you can go straight from here to the answer, right? Because what's negative 4 times negative 2 is going to give us 8. What's negative 4 times 0 is going to give us 0. What's negative 4 times 5 is going to give us negative 20. And negative 4 times 3 will give us negative 12. So that's my solution for negative 4 times matrix A. Now let's do the scalar 5 times matrix B. So 5B means I'm going to multiply 5 times every element in matrix B. Okay, so again, there's my setup. But like I said, this is only to show you what I'm doing, but I can go straight from here to the actual answer. I can skip the step in the middle. So what's 5 times 0 is going to be 0. What's 5 times 2 will give us 10. 5 times 4 will give us 20. And 5 times negative 6 will give us negative 30. So that's my 5 times matrix B. Now here, guys, I'm going to add matrix negative 4A plus 5B. I already did the work here, right? So negative 4 times matrix A gave us 8, 0, negative 20, 12, negative 12. Plus 5B, right, gave us the one that we just did, 0, 10, 20, negative 30. So negative 4A plus 5B, again, here's what actually takes place. 8 plus 0, 0 plus 10, negative 20 plus 20, and negative 12 plus negative 30. So, but if you want, guys, this is what you do here, guys. But if you want, I can go straight from here to the answer. What's 8 plus 0? The answer is 8. What's 0 plus 10? The answer is 10. Negative 20 plus 20, the answer is 0. And negative 12 plus negative 30, the answer will be negative 42. So that's my solution. The matrix is 8, 10, 0, negative 42. Okay, now we're going to multiply matrix. We're going to multiply matrix B times matrix A. Okay, now. So first, I need to find out if we can actually multiply. The matrix matrix B is a 2 by 2, and matrix A is a 2 by 3. So if the two inner numbers match, then it can be multiplied. And the answer will be the outer numbers. Right? The outer numbers will be 2 by 3. So then, here's step 1, right? So I'm going to multiply this row 1 times every column here. Okay, so it's going to be 1 times 2, 0 times 4, plus 0 times 4. Then we add them, it's going to be 1 plus 0. 2 plus 0, the answer is 2. So the 2 goes right there. Then step 2, I'm going to multiply the first row times the second column. And here, guys, I color-coded it so you guys can see what I'm multiplying. Right, so this is my second column. So it's going to be 1 times 0 plus 0 times negative 2. So it's going to give us 0 plus 0. So the answer is 0. So the 0 goes on the first row, second column. Now comes step 3. So I'm going to multiply the first row times the last column, right, which is in red. So it's going to be 1 times 5 plus 0 times negative 3. So it's going to be 5 plus 0. The answer is 5. So the 5 goes on the first row, third column. Since we don't have no more columns right, left, then we're done with the first row. Now we get the second row, which is in blue. And again, I repeat the process. So I'm going to multiply the second row times every column, starting with column 1, then column 2, then column 3. So it's going to be 4 times 2 plus negative 2 times 4. So it's going to give us 8 plus negative 2 will be 0. So the 0 goes on the second row, first column. Now comes step 5. So I'm going to multiply again the second row times the second column, which is in red. So 4 times 0 plus negative 2 times negative 2. So the answer will be 0 plus 4. The answer is 4. And it goes on the second row, second column. Finally, the last step, I'm going to multiply the second row times the third column. 4 times 5 plus negative 2 times negative 3. So it's going to give us 20 plus 6 will give us 26. So there's my solution, guys. This is the answer of matrix B times matrix A. Okay. Now this is something from chapter, I believe, chapter 9. No, chapter 8. It says use the given information to find the following. The U, hey guys, this U here, guys, means the universal set, which means it has A, B, C, D, E, and 1, 2, 3, 4, 5. Set X is AB, 1, 2, 3. Set Y is BD, 1, 3, 5. And set Z equals to B, 2, 3. So solution. Okay, so it's better to write, so this is my X. So since they're finding also the complement, so let's find the complement of X. The complement of X means not X. So you go to the universal set. So it's going to be not A, not B, not 1, not 2, not 3. So whatever is left, that's what's left. Okay, now that's set Y. So not Y means you're going to go back to the universal set. So it's going to be not B. You scratch it out. Not D, not 1, not 3, and not 5. So what's left is A, C, E, 2, 4. And also, here, guys, I didn't put not Z because we're not looking for not Z or the complement of Z. That's my Z, right? So here, going back to part A, let me go back to previous one, right? So let me go to part A. So for part A, we have X intersects, this means X and Y, which means intersection. But I like to also go down to a student's level at times, because at times students don't know what intersection means or what the word and means. So I tell them to it's the same thing as what do they have in common. So you're going to go to set X and set Y, right? So you're going to go here, set X and Y. What do they have in common? Do they have in common an A? No, a B? Yes, right, they have a B in common. They have in common a 1. They have in common a 2. No, not a 2. A 3? Yes, a 3. So it's going to be B, 1, 3. That's what they have in common, so that's your answer. Now, this U here stands for universal set. I mean, not universal set. It stands for union. This guy stands for universal set, but this one here, the symbol stands for union, which means you're going to put them all down, but you don't repeat them. I tell my students, first, write all the elements of X, right? That's X, A, B, 1, 2, 3. Then you're going to go to set Y. Let's go here because it's closer. If the element is already there, you don't put it again. So for example, is a B there? Yes, it is, right? So I don't put it again. Is a D there? No, so let's put the D. Is a 1 there? Yes, it's already there. Is a 3 there? Yes, it's already there. How about the 5? Is a 5 there? No, so let's put the 5. And then you can put them in order. But even if you have it like that, A, B, 1, 2, 3, D, 5, it's the same thing as A, B, D, 1, 2, 3, 5. It's the same thing. Because these are called equal sets, so it doesn't matter the order. But in back of the book, or also in my math lab, they want you to put them in order, but you don't really have to. Okay? Now, for C, it says the complement of X, which means not X, and I already have it here, right? On the right side. So that's your answer. So look at this one here. They want the intersection of X complement and Y complement. So let's go here on the right side. So that means what do they have in common, right? They have in common a C. Yes, they have in common a C. So the C goes there. How about a D? No, they don't have that in common. How about an E? Yes, there it is. How about a 4? Yes, there it is. How about a 5? No. So that's my answer. CE 4. Okay. Now E. X complement intersects Z. Okay, so we're going to go to X complement here on the right, with Z. So X complement, right? So remember, it's what they have in common or where they intersect. Do they have a C, X naught, and Z? No. How about a D? No. How about an E? No, it's not here in Z. How about a 4? No. How about a 5? No. So they don't have nothing in common, which means it's going to be the empty set. Right, so these two mean the same thing. So you can put empty set in this form and the symbols, or you can put like the 0 with a slash over it. That's all it means, empty set. Okay, now for F, right? So it's going to be X union. Let's go to Y intersect Z. It's here on the right, right? So between Y and Z, what do they have in common? So they have in common a B, right? How about a D? No. How about a 1? No. How about a 3? Yes, they have in common a 3. How about a 5? No. So Y intersects Z, or Y and B, or Y and Z is B3. So let's put it there. Now here comes, right, union. So for union, we're going to put all the elements of X, right? The elements of X are going to be A, B, 1, 2, 3. Now we go to the one that we just did, right, to the intersection of Y and Z. If it's already there, we're going to put it again. Is a B there? Yes. Is a 3 there? Yes. That means that's your answer right there. A, B, 1, 2, 3. Okay. Okay, now this is number 19. Let me see what time it is. It's already a little bit over, but let's finish. Number 19. It says 60 people were contracted and responded to a movie survey. The following information was obtained. It says 6 people like comedies, dramas, and science fiction. Why do I have it in red? Because when you use the Venn diagram, you always start where the all three intersect. So that's why I put it in red. And in B states 13 people like comedies and dramas, 10 people like comedies and science fiction, 11 people like dramas and science fiction, 26 people like comedies, and 21 people like dramas, and 25 people like science fiction. So for part A, use a Venn diagram to illustrate the survey's result. Okay, so let's do a Venn diagram. There it is. Here, guys, right, my universal set is 60. Why? Because there's 60 people total. So now, let's see, let the capital C corresponds to comedies. There's my C. Let D stand for dramas, right, for the people that like dramas. There's my D. And that S stand for science fiction movies. Okay, here we go. So to start off, guys, we start off for they all three intersect. All right, there it is. So we'll start with where they all intersect. So it's going to be 6, right? So 6 goes right about there. That's 6. Then let's go in order, right? Then you're going to go 13 people like comedies and dramas, right? So comedies and dramas means right here, back where they intersect. Okay, so 13. So if these two are 13, we already got 6 there, so there's going to be 7 there. Okay. Now, what's next? Let's go 11. It says here the 10 people like comedies and science fiction. So we got comedies and science fiction. So it's going to be this area here. So that's 6 already. To be 10, so that's going to be 4. Then we're going to go for dramas intersect science fiction. So dramas intersect science fiction is going to be this portion here. So that's already 6. This has to be 5 because 6 plus 5 will give me 11. Then it says C, right? People that like comedy is 26. So let's go to C. So all this has to be 26. We got 4, we got 6, that's 10, 17. So this is going to be 9 because 4 plus 6 is 10, plus 7 is 17. And 17 minus 26, 26 minus 17 will give us 9. Now, D, right, for dramas, there's 21 people like dramas. So we're right here, which means all these must equal to 21. I have 6 and 5 is what? 11. 11 plus 7 will be 18. So what's missing here will be 3. And then for science fiction, it's 25. So all these must equal 25. I got 4 plus 6 is 10, plus 5 is 15. So this has to be 10. Now, what's in the outside, right? So we're gonna have to add all these up, and that'll be, and then we subtract it from 60, and that'll be how many people didn't like none of the movies. Right, it's right here. So we got 9 plus 7 plus 6, right? I'm adding all these numbers here. Plus 4 plus 3 plus 5 equals to 44. So then 60 minus 4 is 16. So there's going to be 16 outside. They're in the universal set, but they didn't like none of the movies. So let's answer the questions here. Okay, let me go back here. So for question A, right? So for part A, use a Venn diagram to illustrate the surveys, right? So this is my Venn diagram for part A. Now, we have to use a Venn diagram to answer the questions. How many people surveyed like comedies, but neither drama nor science fiction? So we're going to go to comedies, right? So we're going to go to comedies, which is here, but they didn't like dramas nor science fiction. So the answer will be 9, right? There's my 9. How many people surveyed like dramas and science fiction, but not comedies? Okay, so let's go here. So it's going to be, let me go here. Let me go back here. So how many people surveyed like dramas? They like dramas and science fiction, but not comedies, right? So we're going to go to dramas and science fiction, right? But not comedies. So here is going to be 3 plus 5 plus 10, right? Which is because they liked here, it's in here. How many people surveyed like dramas and science fiction, but not comedies? So this is going to be my answer, guys. My answer is going to be 18. Because we're going to add 3 plus 5 plus 10. These people like dramas and science fiction, but not comedies. So not this part here. Not this part here. So the answer will be 10 plus 5 plus 3. Okay, again, how many people surveyed like dramas and science fiction? So like these movies here, right? So it's been all these right here, but they didn't like comedy. So we subtract all these because these come from the comedies. That's why we add all these numbers here at the bottom. Then for D, how many people like none of the movies? So the answer will be 16, which will be out of the sets, which will be, but they're still in the universal set, but they're not included in none of the sets here. So the answer is 16. This is how you use a Venn diagram to answer some of the questions, guys. But the key thing here is to always start where they all three intersect, which was the 6. Okay, now this is the PowerPoint that I covered last week. It says here a single playing card is drawn at random from an ordinary 52 card deck. Find the probability of drawing a queen. So I put other cards here just in case some students they actually don't know about cards. So here are all the cards. There's really 54 cards, right? But there's 2 jokers, and the jokers are not included here. There's 13 of each: 13 clubs, 13 spades, 13 hearts, and 13 diamonds, which is a total of 52. If you notice, half of them are black, right? Half of them are red, which is 26. And there's 3 face cards for each suit. What are face cards? It's a card that has a face. There you go. So there's 3 for the clubs, 3 for the spades, 3 for the hearts, 3 for the diamonds. Now, go back and answer part A. So I know my sample space is 52, right? Because there's 52 total cards. So what's the probability of getting a queen? How many queens are there? There's 4 queens. There's 1 in each suit. So that's why it's 4 over 52. You simplify to 1 over 13. So that's your answer. For part B, a diamond, right? So there's 13, there's 13 diamonds. So it'll be 13 over 52, which will be 1/4. Okay. Now for C part, a red card. How many red cards are there? There's 26. So 26 over the sample space, which is 52, the answer will be 1/2. Okay. Now for part D, a face card or an ace. How many face cards are there? Right, there's 12 because there's 3 for each suit, and there's 3 times 4 is 12. And how many aces are there? Right, there's also 1 ace for each suit, so it's going to be 4 aces over 52. So it's going to give us 16 over 52, and you reduce it to 4 over 13. So this is the answer. Okay. And I believe some instructors might give you more of these type of problems with cards, but this will give you like an idea of how to work them out. Okay, now this is 21. Now comes where you roll 2 dice. It says suppose two fair dice are rolled. Find each of the given probabilities. The first die shows a 2, or the sum of the result is 6 or 7. Okay? So this is what we're going to be using. The probability of A union B equals to the probability of A plus the probability of B minus the probability of A intersects B. So we're going to let A represent the event. The first die is a 2. We're going to let B be the event that the sum is 6 or 7. Okay, here we go. So it's like this, right? So the first die is a 2, right? So you see this that's here. So you see it's going to be this one's here. It's a 2 because the first die is a 2. So we got 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Which is going to be, right, the sample space will be 36 because there's 6 times 6 will give us 36. So how many are here, guys? We have 1, 2, 3, 4, 5, 6. So it's going to be 6. The number of A is 6, right? So that's going to go here. And then 6 or 7 is going to be 11, right? Because we have 1, 2, 3, 4, 5 that are equal to 6. And there's 6 that are equal to 7, right? So we add these 2 here. So that's why it's going to be 11. So it's going to give us 6 over 36, right? For the probability of A, which is the first die is 2, plus 11 over 36. Now, minus, where do they intersect? Right, where do they intersect? A and B. They intersect here and here. So there's 2. So it's going to be 2 over 36. So 6 plus 15 minus 2 will give us 15 over 36, right? We simplify. The answer will be 5 over 12. So this is the probability, 5 over 12. Now for B, the sum is 11, or the second die shows a 5. So let's do the same concept, right, by using the same formula. So here, guys, right, so the sample space is also 36. The sum is 11. So again, so we're going to let A represent the sum is 11, right? So 11 means it's going to be 5, 6 or 6, 5. So it's going to be only 2 here. We're going to let B, right? We're going to let B be where the second die is a 2, right? So it's going to be a 5, I mean. So the second die is a 5. It's going to be all these right here, right? Because here the second die is a 5. 1, 5, 2, 5, 3, 5, 4, 5, and so forth. So it's going to be 1, 2, 3, 4, 5, 6. So it's equal to 6. Now, where do they intersect? Will be right there. So it's going to be 1. So let's plug into the formula. 2 over 36 plus 6 over 36 minus 1 over 36. The answer will be 7 over 36. So this is your answer, guys. Okay. Now this is number 22. It says, for many years, the state of California used 3 letters followed by 3 digits on its automobile license plates. Okay. So there's 26 letters in the alphabet and 10 digits that make all the numbers. So how many different license plates are possible with this arrangement? Okay, so here we go. The first 3 are going to be letters, and the second 3 are going to be digits. So how many letters are in the alphabet? So it's going to be 26, right? And here, guys, they don't give you a restriction, so it'll be 26 times 26 times 26, and 10 times 10 times 10. You multiply them out, and that's the result, which is something like 17,576,000. Now for part B, when the state ran out of new numbers, the order was reversed. 3 digits followed by 3 letters, right? So these are my digits, followed by 3 letters. And again, there's no other restriction, so it's going to be 10 times 10 times 10, and 26 times 26 times 26. You multiply it out, and you get the same result as part A, because when you multiply, right, it doesn't matter the order, you get the same answer. Okay, I believe by using the commutative property. Now for part C. 7 years ago, the number described in part B were also used up. the state then issued a plate with one letter followed by 3 digits and 3 letters. So there's my letter followed by 3 digits followed by 3 letters. So again, 26 in order, and then 10 times 10 times 10, and 26 times 26 times 26. So imagine, guys, by adding a single letter, okay, a single letter, look at the difference from part B. This was something like 17 million. We 17 million and a half. Here we have 456 million and a little bit more. So imagine, guys, by adding one letter, right, to the plates, look how many plates we got extra. Really, guys, the answer will be 456,976,000 is the answer. Okay. Now comes permutation and combinations. So these are the key words or the clue words for permutations, and here are the clue words for combinations. So it says here, a lottery game requires that you pick 6 different, I forgot to put numbers here, 6 different numbers from 1 to 99. If you pick all 6 winning numbers, you win $4 million. How many ways are there to choose 6 numbers if order is not important? So with part A, guys, you have to see if you're going to use permutation or combination. Here it says that the order is not important, so it's going to be combination because order does not matter. Okay. So you're going to use 99 combination 6, right? And here, guys, you can actually put that in the calculator, right? And this is the answer: 1,120,429,256. Now for part B, how many ways are there to choose 6 numbers if order matters? So this is going to be, right, permutation, because the order matters. So the answer will be 806,781,064,300. Okay, now I believe I need like 2 more or 3 more. So we're almost done here. And this comes from the book. And exercise 59, you pick 5 out of 6 numbers correctly, you win $5,000. And how many ways can you pick exactly 5 out of the 6 winning numbers without regard to order? So the solution, guys, right, is going to be combination. Right, so we want to use 5 out of 6. So it's going to be 6 combination 5. But remember, guys, I believe in exercise 59, there was we had to use 99 numbers, right? 99 numbers. And we had to pick 6. So then it's going to be 93 combination 1, right? Because these must equal to 6 and these must equal to 99. These are the numbers we picked, right? You pick, and this is the total numbers that you choose from. Right, and again, that's what I put there, right? So the 6 and the 93 must equal to 99, and the 5 and the 1 must equal to 6. So 6 combination 5 will give us 6, and 93 combination 1 will give us 93. You multiply them out, so that's your result. Okay, 558. Now, I believe this is the last problem here. A financial advisor offers 8 mutual funds in high risk category, 7 in the moderate risk category, and 10 in the low risk category. An investor decides to invest 3 in high risk, 4 moderate risk funds, and 3 low risk funds. How many ways can the investor do this? Okay, so let's do this. Solution. Again, if you read the problem carefully, order does not matter. So we have 8 mutual funds in high risk, and they want 3, right? So it's going to be 8, invest 3 out of 8, so it's going to be 8 combination 3. And then for the second part, we have 7 in moderate risk, and they want 4, right? So they want to invest 4 from the 7, so it's going to be 7 combination 4. And finally, they have 10 in low risk, and they want to choose 3 from there. So it's going to be 10 combination 3. So you use 8 combination 3 is going to give us 56. 7 combination 4 will give us 35. And 10 combination 3 will give us 120. So we're going to multiply all those out. So the answer will be 235,200. That's how many ways the investor can invest without, we're speaking 3 high risk, 4 moderate risk, and 3 low risk from the given ones, which was 8, 7, and 10. So the answer will be 235,200. Hey guys, thank you for sticking with me for like an extra 20 minutes. So I'm done with my PowerPoint. Let me go back to the original screen. Let me stop sharing. And let me see here.
Thank you, Ms. Assi.
Oh, you're welcome. Thank you, guys.
Thank you. I would like to thank Mr. Zassi for his wonderful coverage of your final exam today. And I'd like to thank y'all for coming and wish y'all a very happy Mother's Day weekend. This is the last TVE of the semester, and we're grateful for having you all, and we'll see you in the summer.